Hey gang, so we're back again with the last of chapter 8.3, and here we're looking at example 3, which is determining a scale factor. So we have kind of a cross-curricular example here, where we're looking at the diameter of an animal cell that is represented by the scale diagram is actually 0.25 millimeters. What scale factor was used to draw the scale diagram? So you can see here that we have our animal cell, and it's saying that the diameter of the cell is 3.5 centimeters, when in actuality, we know that it should be 0.25 millimeters. So in order to determine the scale factor, I'm just going to get my dock out of the way here. What we're going to do is we're going to take the diagram measurement and divide that by the actual measurement. So for us, we take our diagram measurement, which is 3.5 centimeters, and then I have to compare that with the actual measurement. Now, if I put in the actual measurement as is, I'm crossing units. So you'll see I have centimeters over millimeters. So what I'm going to want to do is I'm going to want to change one of these either way. So I'm going to take both of these to millimeters. So I am temporarily going to write in 0.25 millimeters, but then I'm going to change this knowing that every centimeter is 10 millimeters. So if I multiply by a factor of 10, this would actually be 35 millimeters divided by 0.25 millimeters. So if I do that division on my calculator, I'm taking 35 dividing by 0.25. My scale factor is actually 140. Okay, so this is 140 times bigger than the actual animal cell would be. So the summary for this chapter, you should know the key ideas that scale diagrams can be used to represent 2D shapes. To create a scale diagram, you must determine an appropriate scale to use. This depends on the dimensions of the original shape and the size of the diagram that's required. So again, what are you trying to measure and how big does it need to be to fit it on a piece of paper or a piece of bristle board or whatever you're trying to create the model of. The scale factor represents the ratio of a distance measurement of a shape to the corresponding distance measurement of a similar shape, where both measurements are expressed using the same units. What you need to know is that you can multiply any linear dimension of a shape by a scale factor to calculate the corresponding dimension of a similar shape. And when determining the scale factor k used for a scale diagram, the measurement from the original shape is placed in the denominator. So k is equal to the diagram measurement divided by the actual measurement. When a scale factor is between 0 and 1, the new shape is a reduction of the original shape, and when a scale factor is greater than 1, the new shape is an enlargement of the original shape. One thing I'd like to add to this is that when creating a similar figure, the angles stay the same.